Hey everyone, and welcome back to the channel. Today, we're diving deep into a protocol that's set to fundamentally reshape how we build with large language models. LLMs are incredible, but they have a glaring Achilles heel. They're brilliant at language, reasoning, and generation. Their knowledge is static, locked away in their training data. They can't access real-time information. They can't tap into your proprietary enterprise systems. And crucially, they can't act in the real world. This leads to those infamous hallucinations, plausible but factually incorrect outputs, and a general inability to perform dynamic operations. Think about it. An LLM can't natively make an API call or query a live database. The shift from purely generative AI to agentic AI, where LLMs need to reason and act on fresh, dynamic data, demands a robust solution. And that's precisely where the Model Context Protocol, or MCP, steps in. Introduced by Anthropic in late 2024, MCP is an open standard designed to bridge this operational chasm. It standardizes how AI models, especially LLMs, connect with external data sources and services, enabling them to make structured API calls consistently and securely. The best analogy? It's the USB-C for AI. Just like USB-C provides a universal adapter for diverse devices, MCP offers a single unified interface, eliminating the need for custom integration code for every unique tool or API. For us, building enterprise-grade LLM applications, MCP is a game changer. Grounding LLMs with real-time proprietary data is non-negotiable for accuracy, relevance, and compliance. MCP facilitates a scalable, plug-and-play approach, moving us beyond the fragmented, often fragile custom integrations that have plagued AI development. Historically, connecting LLMs to external systems meant crafting bespoke API wrappers and complex prompt engineering for each service. That's simply unsustainable at scale. MCP aims to slash development overhead, enhance consistency, and foster a truly modular AI application architecture. It's a foundational shift, much like standardized network protocols transform the internet. MCP operates on a robust client-server architecture. The host application is your AI assistant or LLM client. It initializes the MCP client, manages connection, captures the LLM's intent, and integrates results. The MCP client is typically embedded within your host app, maintaining direct connections to servers. The MCP server is the service exposing capability, callable tools, read-only resources, predefined prompts. It handles authentication, authorization, data retrieval, and even data masking. And finally, data sources are the actual repositories or systems supplying the information mediated by the MCP server. The technical bedrock of MCP is JSON-RPC 2.0. This lightweight, stateless protocol is perfect for the rapid, dynamic exchanges AI workflows demand, focusing purely on method invocation and response. Unlike resource-oriented REST, JSON-RPC is action-oriented, aligning perfectly with an LLM's need to call a function. This design prioritizes minimal overhead and clear structured communication. MCP uses 4 primary JSON-RPC 2.0 message types. For instance, a request to list available tools, and the server's reply providing a list of tools. A core aspect is tool definition and discovery. MCP servers expose tools that LLMs can invoke to interact with external systems. Each tool has a unique name and metadata, typically using JSON schema to define its expected inputs. This schema tells the LLM exactly how to call the tool. Beyond tools, servers can also expose resources, structured data, and prompts, predefined templates. This dynamic discovery mechanism allows AI models to query for available tools on the fly, eliminating pre-configured integrations. This fundamentally shifts the integration burden from the LLM's internal knowledge to a standardized, machine-readable contract, enabling greater modularity and extensibility. So how does an LLM actually use MCP? It's a structured, step-by-step process. 1. Connect to MCP server. Your host application initializes an MCP client and establishes a connection to the server. This can be via standard I/O for local processes or HTTP with server-sent events for remote communication. An initialized message handshakes protocol version. 2. Discover available tool resources. The client queries the server, typically with method, tools, list. The server responds with a standardized list of tool definitions, including names, descriptions, and input schemas. 3. LLM chooses a tool. When a user's query requires an external action, the LLM determines, via prompt engineering or its native function calling capabilities, that a specific tool is needed. The host application captures this intent, often as a JSON object. 4. Invoke the tool via MCP. The MCP client then sends a tool's call request to the server with the chosen tool name and parameters, adhering to its defined schema. 5. Return the result to the LLM. The MCP client receives the tool's output. The host application integrates this result back into the AI's response, often by injecting it as a system message into the ongoing conversation, prompting the LLM to continue. The host application is the crucial mediator, translating between the LLM's native format and MCP's JSON-RPC. This decouples intent recognition from execution, giving us immense flexibility. MCP isn't just about fetching data, it's about enabling LLMs to become active participants in complex workflows. Agentic AI workflows. MCP is a key enabler for the Agentic AI paradigm. LLM-based agents can now orchestrate and execute complex business operations across disparate systems. Imagine an agent issuing a support ticket, checking regulatory compliance, or reviewing order delivery status across multiple enterprise systems. MCP's ability to maintain context across multiple API calls is vital for these intricate, multi-step workflows. Real-time data grounding. This transforms LLMs into highly informed, domain-specific experts. In financial risk management, LLMs can access fresh enterprise data for fraud detection, risk assessment, and identity verification, ensuring compliance. This directly addresses black box AI concerns. Specialized applications. Beyond enterprise, MCP underpins frameworks like the Internet of Expert, IOX. This equips LLMs with specialized environment-aware reasoning by allowing them to query lightweight expert models. For example, in wireless communications, an LLM could query expert models to detect line-of-sight propagation or Doppler effects without any LLM retraining. This combines the LLM's general reasoning with specialized, verifiable expert knowledge. The LLM context management landscape is crowded. LLMs often struggle with lost in the middle, prioritizing information at the beginning or end of very long contexts. Also, token bloat increases costs and can degrade response quality. MCP treats context as dynamic, structured, composable inputs via a formal JSON-like protocol, focusing on enabling LLMs to access and interact with enterprise data in a governed manner, supporting actions beyond just answering questions. No new technology is without its hurdles. MCP's reliance on stateful server-sent events, SSE, can complicate integration with stateless REST APIs, often requiring external state management. Context scaling. Multiple active MCP connections can consume significant tokens in the LLM's context window, impacting performance and focus. Latency. Real-time data access from various underlying enterprise systems. Maturity and adoption. MCP is new, late 2024, meaning a less mature ecosystem with fewer community tools. Its adoption requires a shift in how developers manage context. There's also the risk of industry fragmentation if other major players develop competing protocols. Despite the challenges, MCP is poised to drive transformative trends. Decoupling of AI models from specific tools. MCP's standardized interface means you can select your preferred LLM and seamlessly integrate it into a common ecosystem of tools. This fosters modularity and flexibility, allowing easier switching between LLM providers and external services without re-architecting. It's a move towards composable AI. Rise of truly autonomous agents. MCP is anticipated to enable widespread adoption of AI agents capable of executing complex, end-to-end tasks with minimal human intervention. It's a fundamental paradigm shift. It provides a standardized, secure, and scalable framework that transforms LLMs from static knowledge bases into dynamic, agentic systems capable of complex, real-world operations. For us, as senior developers, Understanding and adopting MCP isn't optional. It's crucial for building the next generation of AI-native applications that are accurate, contextually relevant, and capable of initiating and managing actions in complex enterprise environments. I highly recommend you explore the MCP protocol, consider building MCP servers for your domain needs, and contribute to its evolving ecosystem. This engagement will be instrumental in shaping the future of AI integration and unlocking unprecedented capabilities in intelligent systems. That's all for today. If you found this deep dive valuable, hit that like button, subscribe for more technical content, and let me know in the comments what other AI protocols you'd like me to cover. See you in the next one.